My name is John. I happen to be a Varian employee, but the SVELC is run by a group of volunteers. I usually have several more partners in crime in this building with me, but some of the major players, some of you might know Kimberly Flame, Mark Lichty, and so they're out traveling. But I do have surgeons right here. Yeah, surgeon is one of the other partners in crime, and we've got a volunteer videographer. Okay, so we do have a bit of a crowd here too. If you have questions, you can catch us afterwards, but we are a volunteer-run organization, and we spread the management load amongst about 5 people, and that keeps this whole thing percolating along amongst all the business travel. So I'm going to get to introducing our speaker, but I'll first make some comments on sponsorship. So one of our sponsors is Varian. They sponsor this facility. So we thank our employer. And we also got food, which you guys have been having, coming to us from Chris Sims of Agile Development. We give sponsors 3 minutes to describe the organization.
All right, I'm not going to use 3 minutes to describe the organization. We have fun for 2.5 and then the sales pitch for 30 seconds. Somebody maybe give me like time every minute if you can. All right, engineering leadership. Real quick, traditional versus maybe more agile. Who in the room is like an awesome leader or wants to be an awesome organization leader and aspiring CEO? I need someone to come up quickly, volunteer. Come on. All right. Okay, you are going to face all of these people. You're stand up here. All right, I need somebody who wants to be like the first person at the startup that he's the CEO of. Come on, somebody quick. You're the actual like engineering mastermind. Okay, we need volunteers, so this is going to get really boring. I will be like a scrum lecture. Okay, so your job is to face your CEO. Okay, now I'm the market. All right, now you are going to direct your team. Put your hand up. Put your hand up towards his face. And you're going to follow his hand. So if he does this, you're going to like move your body this way. Okay? All right, so I'm the market. And I'm going to direct Mr. CEO. You pay attention to the market. He's got the basic idea, okay, but I'm going to like, the market's going this way, and you're going to react to making the company successful. Okay, awesome. Now our company's growing, we need another person. Hurry. This is a lot less fun if we don't have people. And I've probably got like a minute left. Okay, so now CEO, 2 hands, 2 people. Okay, we're growing, we need 4 people. All right, you 2 are now VPs. Each arm, you're going to follow what the CEO says, but direct your people. So go pair up, all right? Okay, so CEO, you're watching the market. People, you got to watch the CEO. Yeah, he's going to tell you what to do. All right. Okay, now you imagine this is going to scale up, they all get more and more people. Okay, now instead we're going to do high visibility. Everybody gets to see what the market's doing and then react. Okay, real quick, how did it feel the first time? The first way, command and control, everybody following the CEO. Slow. How did it feel the last time? Fast. Okay, we'll go with that. Thank you. So traditional command and control versus high visibility and agility. Okay, 10-second sales pitch. If you want to get your certified Scrum Master, certified Scrum Product Owner, or the super fancy new advanced certified Scrum Product Owner workshop and certification, there are flyers with discount codes on the book swap thing. Also up here by the front, if you want to talk about any of that, come see me. Thank you for allowing us to sponsor you. Rock on.
Thank you, Chris. Okay, so I'd like to introduce our speaker, Russ Singleton. He's the VP of Group Biz Dev at Robotics. privately held, commercial stage surgical robotics company. And he's going to be talking to us about Agile for both hardware and software in medical devices and other such things. I just want to throw in somewhat editorial point. Here at Variant, we're also a medical device maker. We have experimented with Agile processes, and you might be aware that the FDA has some constraints, but allows some forms of Agile processes, and I'm sure Russ, you're going to go over that. But even though the FDA allows it, doesn't mean it's easy. Applying Agile to hardware is something that, requires agility and change of mindset. So that's quite entertaining. I look forward to hearing what you have to say about that. And Russ himself has had extensive experience. He's been a CEO, COO. He's been in general management. He's been a VP of R&D. Some of us might think switching VP R&D to VP Biz Dev is downgrade, but maybe your lunches are better.
I'm on the West Coast now. East Coast.
East Coast versus West Coast. All right. So, and Russ also holds a PhD and a Master of Science degree in EE, and also bachelor's from before that. So, Russ, we look forward to hearing you. Can you hear me?
Yeah.
Okay, thank you. So I'm going to talk a little bit about med robotics as part of this whole thing. I thought it was a good introduction that I got. Med Robotics is a company that's based in Massachusetts. I'm going to start just going through a little bit about myself. I have a couple of things about Med Robotics just to give you a sense of what they're doing. It gives a little context to the presentation on product development process. I'm going to talk about Agile and Lean and the concepts that we focused on at Med Robotics, examples of what we did, and then I'll talk about my experiences in using some of these concepts in other companies that I've been in. Most of my career has been in hardware companies. I've had a couple of stints running pure software businesses, and I have a degree in electrical engineering, did my, and a PhD, and I did a lot of my work in optics and in software. So I think about the whole domain. I think of myself as a systems guy as opposed to being a particular domain of either electrical or software or anything like that. Now, jumping into, I've also been in a lot of startups. Good part of my career is in startups, although I've had one stint in Philips. And my span is semiconductor, genomics, medical imaging, pure software, as I mentioned, and most recently in surgical robotics. So it's quite a broad area that I come from. Some of my early experiences, I've been one of my fellow alum from KLA here. But KLA is a company that builds capital equipment and software, semiconductor business. And I was there a couple of times in the 80s and then later in the mid-90s. And then in between was in a company called Molecular Dynamics, which was in the genomics area, where at that time was when the genome was first being sequenced, and we built, among other things, we were developing some of the very first DNA sequencers. Later on in my career, I was at Philips Healthcare, where I ran a business that was doing imaging, gamma imaging, it was quite a large engineering crew that we had there, larger products. And then I've been in consultants for both in medical and non-medical areas, and then more recently at Med Robotics. When I was at Med Robotics, in the R&D role, I was based out in Massachusetts. I was living there. We were living in a house that we rented on the coast. But my house is here, my own home is here, and so I was looking for an opportunity to come back, which is where I am right now. We're back in Palo Alto. So, just a couple of notes. This presentation that I'm doing is, I've got help from Kimberly. I think a lot of you know Kimberly Briefling from Either Rao. She did a presentation, has done a lot of work on lean and compliance, medical device product development. She is a consultant with the FDA. A lot of what we are doing is medical device, so I'll talk about that. From Roger Tang, and I'll refer to, has done a lot of work comparing with lean and agile methods, mostly for hardware development. And then internally within robotics, a woman by the name of Danielle Lombardi who gave me help on this presentation. So software, hardware, software development, a question for you. I'd like to get a sense for the people who are here, where you're coming from, whether it's where you see yourself in a software company, software-owned company, or you consult for a software company. Just kind of raise your hand, get a sense. So maybe a third, something like that. You can raise your hand multiple times. This isn't, you have to be in one particular area. I know people work in multiple areas. Who's in a hardware company? So, okay. And here's a trickier one. Who's from a medical device? Okay, so it's about a third, is what I'm seeing, which is good. That's a good cut across the whole organization. All right, so I'm going to talk a little bit about lean versus traditional, and I'm going to come back to Agile in a minute. Lean product development, for those of you who've been around, has been around for quite a long time. It came out of Toyota, and if you look at the Agile manifesto, it's based on lean. So, if you look at the principles, I'll show you that in a little bit. They're very similar in a lot of ways. Lean product development has twin pillars. It's respect for people and continuous development. And those are really the big themes, very similar to Agile as well. It's people working together, having respect for people in the organization, and in continuous development, cycles of learning, cycles of knowledge building that you're trying to go through. You're building up knowledge that you can be basing where you're going from as you go forward. If I have a laser pointer here, I think I do. It doesn't show on the screen. Maybe I can do this with the. Does this show? No. One of the concepts of lean that it reflects a lot of similarity between lean and Agile is short cycles of doing product development every 2 weeks or every 4 weeks, delivering value fast. This is a concept that I'll talk about in a little bit that we really built on at robotics and in a hardware way, so we'll talk about that. It's based on what the Japanese call Kaizen, short cycles, deliver value fast, be able to learn. And then be able to respond to changes that you find. And then the second big piece is what the Japanese call GO-C, which is really going and understanding your customer's problem. As we talked, as the gentleman who came up earlier, it's really understanding where the market is, but it isn't just understanding from a market perspective. I recently read a book by Clayton Christensen, which is understanding your customer's job. What is his job? Which is basically not understanding how you're going to provide value for him, but what problem is he trying to solve? So when you're trying to provide a product for your customer, you want to understand what problem they have and where is their pain in terms of what they need to do to be successful, and try to address that. If you're able to do that more successfully, you will find yourself in a situation where you'll get better adoption. And if you just say, I'm going to do a better widget because you're thinking from your perspective. This is all about understanding from the customer's perspective what his job is, rather than what you're providing to him. And so the concept within lean is really going, what the Japanese talk about, or Toyota talks about, is going down, they talk about manufacturing, sometimes going down on the manufacturing floor, really understanding what's going on. But it applies to your customers, it applies to wherever you're providing value, wherever your customer is. It's useful to compare, this is the Agile, probably familiar to a lot of you, the Agile Manifesto. It's all about, what it talks about here is individuals and interactions over processes and tools, working software, meaning being able to do it in cycles, being able to get value quickly, customer collaboration over contract negotiation, understanding what your customer needs are, getting them involved in what you're doing, and responding to change. Lean product development has all the same attributes, it is really, the way I think about it is these 4 things are, that's one.
It's a warning timer.
Okay, I don't think it's you. So I talk about, there's something like 13 principles of lean. I talk about customer-defined value, being able to understand that up front-loading the product development process. I'll talk about how we do this at Med Robotics to really understand what technologies we want to do to solve that problem. And what I haven't talked about is creating a level product development flow, which is something maybe more suited for hardware than it is for software. I'm not going to go through all these 13 steps. What I want to do is I want to get to what we were doing at Med Robotics and be able to give you a sense of what changes we made over there. Agile also has a similar set of principles, very similar. If you map them, you will find that they're maybe not the same number, but I've gone back and taken a look at it, and it is very similar kinds of steps. So the part of what we were doing, obviously, and a key part of what we're doing is in medical device. Medical device is under oversight of the FDA. For those of you who are in medical device are familiar with the famous Waterfall, where you have to go through a set of prescriptive steps in the process. You say, well, how am I going to do Agile or how am I going to do anything fast in this kind of thing, because I have to define it up front and I'm stuck. And that's not really true. I keep pressing the wrong button here, so I apologize for that. A nature of medical devices, you do need to follow, you need to have a design control process that you would find within your company that gets audited, and you have to follow it strictly. You cannot sell in the United States without getting 510(k) clearance. You cannot sell in Europe without getting CE mark approval. But you can get doctors and surgeons to work with you in development, so you can get your customers in. As I will talk about here, what we ended up doing is bringing our customers in, working with us very early on, building prototypes that they were able to do surgery in cadavers and really get some feedback that way. Also, the nature of robotics development is it's systems development, so it's software, electrical, mechanical, optical in our case. And unfortunately, in a situation like that, a lot of times software is tested last. It's not, you need the hardware to be able to know if everything is working. It makes it a little bit more difficult. The hardware must be functional enough for the software to be tested adequately. And when you do integration, it's the only way you can fully test whether what you're building really works. And then knowing medical devices does not imply knowing systems and vice versa. It is possible to get all the way through the process. And we've had this where people come in inside of our company when it was a startup. As it started, people came out of the mechanical regime, and it wasn't until all the way through the whole process they really found that they missed stuff. So you really have to be thinking about the whole system when you're starting out. So I'm going to do a video here to give you a sense of
Surgeons at the University of Pittsburgh Medical Center are the first to use a flexible robot to perform head and neck surgery.
The concept of flexible robotics is going to be the next revolution in surgical advancement, surgical science.
Krista Kaufman was one of the first patients to be operated on with a flexible robot. She had a growth on the back of her tongue. Without this new tool, she would have had a large incision in her neck, which would involve reconstruction and a longer recovery. More rigid robots are better suited to work on the joints, the abdomen, and the chest where there can be more room. But in the head and neck, the structures are smaller, curvier, and flexibility is a distinct advantage.
Tumors in the back of the tongue, tonsil, even of the larynx or the voice box region can be addressed with this flexible system. That'll be followed.
Regan, Krista is glad surgeons were able to remove her growth with this new, less invasive technique.
I thought it was cool. There's going to be a trainer in the back of my throat for a little while. It's going to fill in, and then everything's going to be pretty normal.
Researchers say additional flexible robots are in the works that can be used for other surgeries. Dr. Maria Sembra, CBS News, Pittsburgh, Pennsylvania.
So let me go back and talk about robotics a little bit so you understand where we're coming from. So the company is a startup. I was talking a little earlier before we started. Is it a startup or is it a late stage, small company? We're privately held still. We're high net worth investor funded. It's not venture funded so much. But we have raised to date over $200 million, and we're in another round of funding right now. So it's raised quite a bit of money to get to where we are. It's a spin out of Carnegie Mellon. The company was founded on what's called snake robot technology. I have another video a little later in here that'll show you a little bit about what that is all about. You can see there was quite a span of time, but we did our first human use study in 2010. And it took us another 5 years to get clearance, both in the US and in Europe. So it takes quite a bit of time. This is not something that you can do as fast as you can do something a little less complicated. And then in 2017, we got clearance. So the first clearance that we got was doing surgery in head and neck, going through the mouth, being able to go down to the base of the tongue. A lot of the surgeries that we do are for cancer. And then in 2017, we got clearance to do colorectal surgery, so through the anus, to be able to do large tumor excision and that kind of thing. So in answering a question I had offline, we do have clearances, and we are able to sell in the US. The nature of the clearances they're not specific to a specific application. We can do surgery anywhere in the anatomical region. This is how we got granted in doing the surgery. So anywhere in the head and neck, and anywhere inside of the colon all the way to the first term. When I joined as a consultant at MedRobotics. I joined around 2015. A lot of effort was going on in product development, focusing to get to the first clearance. I learned before I came on that they had been trying to get clearance in Europe for 3 years and failed. And I came in to basically see what was going on with the team and do what I could do. What I found, and this is very different than Agile, very different than Lean or anything else. Everybody was working in silos. So we talk about communication. People weren't communicating to each other. This was like mechanical engineers were doing their mechanical thing, electrical engineers doing their thing, and software were waiting for everybody to get to a point and then trying to get their working system going. And it was caught in what's called design control. For those of you in the medical device area, you might recognize that situation where everything that you're trying to do, every component that you're trying to do is constricted because you have to sign half a dozen signatures to be able to make a purchase or a design change or something like that. It's pretty hard. And the team was struggling, had a lack of clarity of what to do next. So I'm close friends with Kimberly. I got her on the phone. We were talking about what we were doing in some of these things, and basically we did some very simple things. Prioritize ruthlessly. It's like figuring out all the things that you had to do. The story that I tell is I asked the team to figure out where they needed to, what they needed to do to get done. And we made a list of about 1,000 things, literally, on a spreadsheet. And I said, okay, great. You did a great job. Now let's bucket that. And they came up with 10 buckets. 1, 2, 3, 4, 5, and they had 100 things in each bucket. And I said, great. Now let's take that bucket, number 1 of 100 things, and let's prioritize those things. A, B, C, D, you're done. We actually got up to G, but I said, that's it. That's all we're doing. That's prioritizing ruthlessly. The other thing that we did is we put small teams together. So this is very similar to Agile in the sense of no team was more than a few engineers. And they would have to do, they couldn't define anything that they couldn't see at the end. So it wasn't 2 weeks, but they were time boxed. You had to get something done in, say, 3 weeks or 4 weeks and produce the results and get to it. And then we would lay out the projects along that way. And we called these micro projects. And it was very effective because what it does is it gives you focus. It gives the team extreme focus. It isn't like they're trying to think about all the different things that have to come out. It's really focused on what they have in front of them. And then when we did the prioritization, and I'm very proud of the team, I asked them what was the number 1 thing they needed to do. It was go figure out what the customer problems they needed to solve were. The team came up with this. I would have forced it, but I didn't have to. And it was really going back and getting the surgeon in and trying to understand what those needs were to drive what we were trying to do. So that gave clarity to product development. So with these sprints and small scope products, we call them micro projects. These were cross-functional teams, so this is what you'll find in hardware development, where the agile silos, mechanical, electrical, and software work together on one problem. Not you guys do something and then I'll work and figure out what to do. So everybody's trying to solve the same problem. So they're learning each other's area. And towards the 3/4 of the way into the program, we did provide a healthy incentive program where everybody practically everybody in the building who was working on the project was then incentivized. And we paid the incentives out as a bonus that was paid every 2 weeks in sprints, if you will, to hit bi-weekly objectives. And the outcome is we did get CE mark. It took us 12 months to do that, but that was pretty significant. And then we finished the release of the product to Europe. It was another 3 months to get to that, and we did our first human surgery. And then it took us another 15 months from the CE mark day to get clearance in the US. But by that time, we had something like 80 surgeries done in Europe, and we were able to use the data from Europe to be able to get clearance in the US, which is pretty unique. And that's a whole story in itself. And so we're selling now, and as I mentioned, we've gotten clearance in other areas as well. So this will talk a little bit about the company and the product is a little longer.
The MedRobotics Flex Robotics System is the world's first commercially available robot-assisted surgical platform with a flexible robotic scope. The Flex robotic system offers surgeons the unique ability to define a non-linear path to a surgical site and achieve exposure that would be difficult or impossible to achieve with minimally invasive straight approaches. The robotic scope is comprised of inner and outer mechanisms. The surgeon advances and steers the outer mechanism, and then the inner mechanism follows, creating a stable surgical platform from which to operate. By combining the flexibility of an endoscope with the strength of laparoscopic tools, the Flex robotic system creates new possibilities for minimally invasive surgical access. The Flex robotic system has a small footprint and is highly mobile, integrating easily into the OR. And because the setup and learning curve are easy and quick, the system can be efficiently integrated into hospital operations. Utilizing HD visualization, surgeons can enter the body through a single small entry point and maneuver around structures to operate in difficult-to-reach places. Today, access is gained through the anus and the mouth. In future applications, access may be obtained through the other natural orifices, such as the vagina, or through small incisions in the abdomen. Learning to operate the Flex robotic system is easy because it has been designed with a familiar joystick-like controller. Thus, driving the robot is instinctive, resulting in a short learning curve. The Flex robotic system provides visualization and surgical site access for transanal procedures in the anus, rectum, and distal colon. Surgeons are able to not only reach anatomy that may formerly have been challenging to access or inaccessible, they can improve their angle of approach, achieving exceptional exposure. The Flex robotic system provides visualization and surgical site access to the oropharynx, hypopharynx, and larynx. The larynx is an area that can be particularly difficult to access with straight instruments. With the Flex robotic system, surgeons are not only able to see more and reach more, they can also treat more patients with the MedRobotics Flex instruments, as well as other compatible instruments. The Flex instruments are based on the same innovative technology platform as the robotic scope. Surgeons are able to articulate and rotate instruments that combine flexibility and rigidity. Further, MedRobotics offers a full suite of instruments suitable for transanal procedures. The instruments are inserted through an instrument support and follow guide tubes positioned along the robotic scope to quickly and easily reach the surgical access point. The surgeon is able to sit or stand comfortably as they choose, while also remaining at the patient bedside throughout the procedure. The MedRobotics Flex robotic system provides exceptional exposure and access to the operative site, while allowing for consistent instrument triangulation from the anus through the rectum and into the distal colon. The MedRobotics Flex robotic system. See more, reach more, treat more.
So, when we got the first product out, we did it basically by just force-fitting everybody to get, go through short cycles and everything done. We didn't really change the product development process. We still had the heavy product development process, the Waterfall process that existed in the company, where one step leads to another step. You have to define everything up front, and it is really difficult to go back and make a lot of changes to where you're going. This assumes a one-stream model of product development, and stages are separated by gates, hard gates, and it's a model that's been around. It works when you have a really clear idea of what you're trying to do. There's two different approaches to product development. The traditional, which is design then test, upfront planning, manage test, task completion, and it assumes work is transferred in large batches and maximizes utilization, which means everybody is working hard, but it doesn't necessarily mean moving forward. Lean and Agile is basically test and then design. It's basically the idea of using development to figure out, do I have the right thing? How do you do that? And I'll talk a little bit about what we did. It's rolling wave planning, being able to iterate and build your knowledge before you go forward. Work transferred in small batches rather than large batches, and this can happen throughout the entire development process, but it helps by doing it a lot of the work up front, and that it maximizes the overall time to get to the final product. So what's usually wrong with traditional product development? Difficult work typically is done in the design phase. You define what you're trying to do, you say, I know my market requirements, and I'm going to design it. And then you test it out. The problem is that by the time you get to the market, you build a product, you get out there, it doesn't work the way it was supposed to work, or I have problems. And I'm sure a lot of people who have been through this whole process where this, to really get it right, I'm stuck with that architecture. So what we did is we introduced the concept of phase zero. Phase zero as a concept has been around for a long time. We call it phase zero on steroids. And the concept is really understand what you're trying to do, but not just understand it, build what you're trying to do. Get the searches in and build as complete a product as you can, or complete sub-projects of what you're trying to do. And prototype, test, iterate, and then change it if you have to, and continue doing that until you really think you have it right for what your first product cycle is going to be. And then go into design control. And we did this outside of design control. For those, this was, for Med Robotics, this was a real organizational tug of war. Because there were people inside of the company who said, you cannot do that. You have to do everything under design control, which means you had to get signatures all along the way. What we did is we kept this outside of design control, and we were able to get agreement with the FDA and alignment on that whole process. We released products that way. What it does is it brings the heavy lifting, if you will, up front, where you're doing the iterations, and you can change your process so that your documentation will follow what you're doing. And I'll talk about a more robust way of making changes to the process. But let me talk about what this iteration cycle does. So we had 4 generations of rapid camera development. We saw on the video, we use chip-on-tip cameras. So the optics are on the tip of the robot, the first generation of this thing was 800 by 800. It was not even real time, it was pretty slow, but it got us out to market, and we were able to insert it. Second generation of that product, we built a 2D HD on the same base. But what we ended up doing when we did this, that first iteration, that first process, is we took 2 guys who were doing this in what I call phase zero on steroids. They built it up, they got it working, and then we went into proper design control product development after we had it working and we knew what we were trying to do. And it shortened the process of getting this thing out to market quite a bit faster, and we knew what we were trying to do. And then we've done this, we iterated again. This was part of a larger development, but we made this a detachable camera. It's sterilizable, reusable, up to 10 uses. And then a 4th generation, which is 1080p, 1920 by 1080, diffraction limited optics, a detachable camera, and it's relatively small. You can go down in your mouth, all the way down to the base of the tongue, and go into your colon. And there are generations that are being developed now that are even smaller than what we have It's really limited by the sensor size and by the what you can do with optics to say the resolution that you're doing. But this is pretty high quality images that we produce. So the characteristics of this phase 0, I incorporated the IDO concept of ideate, prototype, iterate, many cycles to do that, to drive rapidly to get designs that you can then get the process started. And the endpoint for that iteration is with the surgeon. So the surgeons come in and do the testing on a cadaver. We had ORs, we have a couple of ORs in the building where we can do that kind of work and do the testing. And then at that point, you can go on into development. So in the case of the camera, it's hardware, electronics, mechanical, software. We've done this in, I've heard people say, well, I've got a pure mechanical thing, how do I do that? So we have surgical instruments. And one of the tough problems that we had in surgical instruments is with a set of scissors that we were trying to make for laryngeal surgery. So surgery down in your voice box. The instruments are, you can hold your finger up 2 millimeters, the size of the jaw is 2 millimeters. Very, very tiny. And you saw the shape of the robot that will go down. This is with a flexible instrument. Try and do cutting where you're trying to pull jaws that are on the length of a rope. That's what you're trying to do. It's very, very hard, but there are ways of doing it. I'm not going to tell you, because that's part of the technology that we have. But we were able to solve the problem. It took us 11 tries over 4 months to be able to do that. And each one of these was try and build it. We were talking about using, we were using all the mechanisms that we could think about. 3D printing for some of the plastics, sintering tools for some of the metals, trying to, whatever enabled us to do things as quickly as you possibly can. And again, this is in a phase where we're not under design control, so we didn't worry about, we thought about, this has to be a medical device product, so we will have to use metals and things like that, which will be biocompatible. But to get the basic technology working, what you basically have to do is get a proof of concept and do it in such a way that you can do it in surgery with a cadaver, with the surgeon coming in. It was pretty remarkable to get that out. And when we actually got the product out and we were doing surgery with these scissors, they told us that this is as good as any instrument on the market, straight, rigid type of instrument for doing that kind of surgery. These are very, very sharp scissors and really can cut. So now the hardware. We said, okay, now I talked about how we did phase 0 on steroids. That's great. That's not the whole process. So the FDA actually gives you a lot of leeway. They tell you you can do concurrent engineering. Friends from Varian said they're doing some similar things. So from strict waterfall to concurrent engineering, the method of designing and developing products with different stages runs simultaneously. So the concept is you have to do all the work, you have to do all the documentation, but you don't have to do them one after the other. You do some of them in parallel to each other. And the idea is to do activity overlapping and information transfer in small batches. So the idea is to have small teams working on it. So the concept is taking this original design control process, but laying on phases that go in a V shape. And I'll show you a different way of looking at that V. So on the left, you have all the phases that have to do with the design of the product. And on the right, all the things that have to do with testing. The trick here is that they're all linked. If I find a problem in a later stage, I can go back. I'm not frozen. All the way up to changing the requirements of the product. If I learn stuff that allows me to do this. This means that you have to have a flexible design control system that does that. Yes, you have to do things with signatures, but you can. And as you come down one side of it, you're learning more and more progressive collaboration. And as you're testing, you're progressively understanding and closing the design as you go forward. So the concept is basically doing this and thinking the whole thing in iterations. And I'm not going to go through the detail of this, but basically as you go forward, as you're doing multiple iterations, what you're doing is you're building up knowledge. And you want to capture that knowledge, and you want to be able to tighten your understanding of the overall problem. So the characteristics of the full board development, again, with a nod to Kimberly Leafling, with extreme focus on the customer, we're trying to satisfy the job of the customer. In this case, in our case, it's a surgeon. So really understanding the surgeon and what their needs are. Understanding risks and accelerators. And so here's another concept. I'm not sure this is from Agile, but it is from Lean. It's the idea of using multiple paths. So we have a B plan, a C plan, and D plan in parallel. And they all vie on the same thing. If A doesn't work, we have B going. And similarly, if B doesn't work, we have C going. Ruthless prioritization, which I've talked about, and challenge assumptions and beliefs of what others think is not possible. Using surgeon feedback, this is critical. And all along the way in the product development process. And where possible, iterating. So I have 4 examples to go through. I'm tearing through this presentation faster than I thought. When we first came out with the products, we were aimed towards head and neck. It was head and neck clearance, and we needed to develop for going into the colon. So we ended up taking the technology for the robot, which is that blue thing there, and leveraging it to be able to go in through the colon. And again, a lot of what we were doing was the same kind of process. We ended up deciding that what we wanted to do is build a product that we could get clearance. So remember, we're a medical device. We have to be thinking about the FDA the whole time that we're doing development. And so our first objective was to build a product that we could get clearance with, that was close to final. And then we ended up going back a second time with the FDA, the updated product, which allowed us to cut a lot of time out of it because we knew exactly what we needed to be able to do. So the getting to the clearance, the submission candidate took 5 months, the second product. The same product getting to commercial with iterations took 9 months. We ended up getting this product out in 2017, just 2 years after we came out with the first product. Second application is an application where in a span of 4 months we were able to take that robot and make modifications so that we could go through the umbilicus, the belly button. And we ended up deciding that, so a key part of the way we do product development and approach the FDA inside of robotics is we separate out the clearance for the robot into visualization and access only. So we have clearance on the whole robotic system without the instruments. And then we get clearance on the instruments separately. So 2 separate paths. What it enables us to do is we can say, we're not trying to do the whole surgery in one shot. It's maybe a way of looking at approaching the FDA with a little bit of agile thinking, but breaking it into a smaller piece, and it's been pretty successful for us. So in this particular case, this is one aspect of it, being able to do access and visualization without the surgery of having the instruments. We got clearance very quickly on this thing from the FDA. Almost a little less than 4 months. And then the next example, I talked about a little bit about what we were doing with the scissors. This is where we did the product. It was all mechanical, no software, no electronics. But being able to, on each of these things, being able to iterate really quickly in a phase 0 type of environment. And then once we had it done, do the submission and get it done. And I can't say a whole lot about this, except that we ended up doing a next generation fully robotic system. We did it in what we call the concept car in a period of a year. And what was unique about this is we took the concept of Agile, where we would go to do sprints, 2 to 4 week sprints of full systems. You start out building components and pieces of components, but once we had enough of them to be able to, okay, we're going to shoot for Thursday of 2 weeks from now, and we're going to do testing. And everybody's going to be involved in doing that testing. And what it forced us to do is follow a cadence to do the development. And it is pretty effective in getting people wrapped around the idea of getting something proven. So this is hardware, mechanical, electrical, and software all working together as a team. And when you do that, it's mechanical guys taking advice from the software guys and vice versa, a little bit, but they're all understanding each other's problems and understanding the way to do this. And this is not, again, this is again in a phase 0 type of environment. So that's it for the robotics situation. I just have a few other examples. Going back to the examples of lean, I wanted to talk a little bit about customer-defined value, the level of product development process flow, balancing functional expertise and cross-functional integration, and integrating suppliers, because I've had experiences in different companies on this. And customer-defined value, I think, is a holy grail. It's basically really building something that meets customers' needs and building prototypes to iterate, to get feedback on that. And the idea in software, I think, is pretty straightforward. And hardware is we do the same thing in hardware. We build hardware prototypes and then getting the customers in our case, surgeons, to be able to understand what you're doing. This works in other environments. I ended up learning how to do this originally at KLA, in KLA 10-4, when we were going out and finding products for the semiconductor industry. We did this at Philips when we were building our spec systems in terms of trying to get feedback with surgeons coming in, and I'm just trying to get really precisely what it is that they need to happen. So this is all about making sure you're going down the right direction. And then, obviously, at Med Robotics, bringing in surgeons to do cadaver studies on prototypes. The concept of product level development process flow is a lot of words, but basically it's the concept of current engineering that goes back 30 years. It's been around for a long time. And the idea of 4 teams. Basically, this is where you have mechanical engineers and service engineers working with the design engineers throughout the development process. And same concepts of what you're doing as you're building out what you're trying to do. You're still using the iteration, some of the other ways that you're doing that. But by getting particularly the manufacturing people up front in the development process, it saves you a lot of problems later downstream where there's no surprises is what you're trying to do. At Molecular Dynamics, over a period of 4 years, we did 16 hardware development releases. Now, these aren't as big as the KLA ones. These were 20 to 60K products, but these were full systems, software, hardware, mechanical, optical. And in the case of Philips, we were doing this for next generation product. It took us several years to get that one product out. But the difference in quality when we came out is that I don't remember the number at the moment, but we use the NPS score to be able to score ourselves as how we met our customer needs in terms of quality. And we scored, I think it was 4 out of 5 on the NPS score. And rated very high compared to the other businesses in what we were trying to do. So it makes a significant difference. In the picture there are engineer, service guy, marketing guy, the different people who were contributing to the development, not all engineers. And then the concept of balanced functional expertise. So one of the concepts is you really need what Lean talks about is having a chief engineer, someone who's got more wisdom than everybody else, leaning in and giving expertise, their expertise to how to do the development. What I've done in a couple of different companies is you really need to have particularly for systems process, a cross-disciplinary structure versus a functional structure. So whenever I come in and I'm running engineering, I don't have a mechanical engineering group or electrical engineering group. The software is a little bit different. So you have to have your expertise there, but where you can, you lend your software guys to the smaller projects. And you really want to keep your team small. You're not trying to have large teams. It's breaking your project down into smaller and smaller chunks, if you will. This works across different kinds of industries.
Can you comment on that chief engineer? What's the importance of that?
So the way Toyota looks at it, it's someone who's got a lot of experience in multiple developments, who is not engaged in the development directly, but is able to be a coach and mentor to the engineers who are working on the projects, and give them, say, I've been through this before, this is what you're doing. And the concept, again, is management of walking around, going in and getting involved in the different projects that are going on. So it's, I tried it in robotics with a very smart physicist, but he didn't have the attitude that you needed for that. You have to have an attitude of, I'm here to help. I'm not here to boss. So,
Okay, I hear you there, but I'm just a little curious because the title implies chief technical decider. Like you're saying that's
I know. There's an article I can share with you about how Toyota looks at it. It is not that. And the concept of the title of chief engineer typically means I'm the top of my totem pole technically. Yes. But I get to boss everybody? No. No people who don't have any authority. And that's a little bit different.
How would the concept of a product owner fit in here?
It is like the sponsor for the development. The way I think of a product owner is it's someone who is understanding the market need. Well, chief engineer should do that too, but it's understanding the market needs, working with the team to make sure that they stay focused on solving the customer problem. It could be, I've seen it from the marketing side or from the engineering side, but it's really key that that person knows what's going on, and maybe the leader of the program or not.
When you talk about customers, it's clear that you're talking about the surgeons, but did you do any research on actually the patients and how they might, receive this?
Not in robotics. Basically, in that particular situation, the surgeons were the ones that we were trying to solve the problems for. Obviously, their customers are patients. So we need, going back to what I said about Clayton Christensen's way of looking at the problem of the customer, we need to understand how they view their patients, and they want to have patients that have good outcomes. So clearly, that's a key part of it.
When you built your cross-functional teams, did you change the organization structure too, or did
Yes.
you still?
Yes.
So you didn't have like a mechanical engineering manager people?
So I've done it a couple of different ways in a couple of different companies. What I did at Med Robotics is I had someone who wore mechanical engineering hat that they were as a lead in the organization or a director or something like that. But they didn't have any direct reports in the mechanical line. Their direct reports they ran a program, but they became the go-to person for mechanical problems across all the different projects. So, engineering, I'm not telling anybody anything they don't know, is a set of disciplines that you want to be able to increase your expertise in whatever you're doing. So you need a go-to person who's been around the block, maybe a little bit like the chief engineer, but a lower down the level. But the strong structure was along program lines, project lines. And that's where the day-to-day marching orders came. And at Med Robotics, we did a similar thing. We did along project lines. So you could lean on other people, but your boss was along the project line rather than the other way around.
So kind of following up on that question, it seems like all the times when we're in those projects, sometimes the software guys and the guys out, so the electrical and mechanical, so we get along really well, and it's just kind of work with each other, but just the software methodologies are so much different, and it's really challenging. How did you solve that problem integrating those disciplines together?
Well, so it depends on the kind of products that you have. So at Philips, so let's talk about the system first of all. In the systems case, when you're doing mechanical, electrical software together, the nature of the software is typically automation or something to do with data inside of the actual piece of hardware that you're doing. So they're very intrinsically involved in that development, and they have ideas about what to do. We also have groups in the Philips case that were doing the imaging platform, the analytical imaging, which was pure software. That was a pure software program, and those people, there was very little hardware involved in that, so they were structured a little bit differently. It was just a set of different projects. Med Robotics, it was really a pure systems approach that we had. We had a software team, but the chief software guy was really a systems guy. He understood a lot of the other aspects of what was going on, and he understood imaging, and he understood algorithm development, he understood robotic control, and that was the type of people that were going to the organization.
That makes a lot of things.
I'm sorry?
That makes a lot of sense. Thank you.
Okay.
Could you, one of your earlier slides made reference to having towering expertise in your employees.
Right.
And I was wondering if you could speak a little bit more about towering expertise.
That's a bias of mine. I like to hire and bring people onto the organization who are smarter than me and smarter than anybody else in the organization. So, and you want to cultivate that. You want to cultivate people who really are very capable. I also happen to believe that product development is a team sport. And the danger that you run into that is you get towering arrogance that goes along with towering expertise. And if I'm running the organization, I'll never even put it quickly. You're going to have to figure out a way of getting people who are a little bit more humble to be able to work with other people. But the towering expertise and I can think of a lot of cases and a lot of people in my mind, they see stuff that other people don't see in terms of solving problems. And it's difficult not to, when you're doing very, very complex products, you need that capability, whether it's robotics or optics or whatever your technical problem is. Someone else?
Regarding the software, regarding the software and hardware boundary, do you have a separate team that works on more of the embedded software, or do the software people work through the whole spectrum from the embedded software to the actual, let's say, user interface? And do the, for example, electrical engineers also work with the software stack?
So there's a limit to how much you can do the combination. Obviously, if you're doing user interface software, right, and it's a bigger project, that's going to be mostly or all software when you're doing that, and that'll follow a different model. And in that case, you can use a pure scrum approach, if you will, to iterate in what you're trying to do. So it depends on what the subsystem that you're trying to address is. The one I think about a lot, the two I think about a lot are robotic control, which requires software and requires mechanical and requires electrical. And a lot of the times, the problems that you run into have to be solved or you're mitigated a little bit by software. But here's a little secret about FDA and robotics. It'll be decades before you'll ever see an AI-controlled robot out there. The FDA requires you to have all mitigations for safety issues mitigated by hardware, mechanical or electrical, not software. They are still in the mode of saying, software might stop working. I don't want to depend on it. So it could be your day-to-day mitigation, but you have to be thinking about the whole system.
Is that like a ESOP system, or is that more kind of complex systems, like if you have a user interface and something fails?
Not really, no. It's, so let me think of the case in point. The case in point that illustrates my problem is when the robot is inside of the human, inside all the way there, and what happens if the power goes out? The robot goes limp, yank it out, 3 seconds. No software required, no electrical required. You take out all the power from the earth, it just becomes limp. So you have to be thinking about mitigations from that perspective.
Maybe still relating to kind of software and the regulations for the related that it has to be hardware. So where does FPGAs fit in here? Nowadays you build fighter jets, you put just FPGAs there so you can update them later. Is there like a shortcut with FPGAs?
FPGAs are software.
All right.
And we have tons of them.
Yeah, I just comment on one variant. Russ is correct. FPGAs are software, but there are chips which you can burn. You can burn in place, and the whole point being that what the IEC 60601 safety regs say is if you have to physically replace a component, then it is a hardware mitigation. Even if you have to physically replace a burned chip, that's still a hardware thing. But if you can do an online update to a burned chip, well, that's where they get nervous. And that's really a problem. Anybody else?
Unpack the acronym, FPG. Anybody?
FPGA is a field programmable gate array. It's like a completely software-defined circuit. Yeah. Okay, but let's okay.
During your phase 0, I mean, you just talked about safety. How much, being outside of design controls, were you doing risk management, and did you have some sort of exit criteria for phase 0?
Yeah, so
So,
We did,
So,
and what we wanted to do,
that's kind of two
we had a performance criteria that we set up. We did have some documentation supporting phase zero. It wasn't completely without that. So we set up a set of targets for what we were trying to achieve, what scientific knowledge we were trying to put to bed, and what customer knowledge we were trying to put to bed. The idea of phase zero isn't just technology, it's about understanding the customer problem with the technology and making sure it solves it. So it would be visualization, let's say for 3D, being able to image with the surgeon so that he can cut in layers with 3D and be able to do that effectively on a cadaver. And that doesn't require you to have a full-blown product, but it does require you to have a full-blown prototype with the software and the hardware and everything working. So it's pretty far down the pike, if you will. Things don't have to be burned into the final product. It doesn't have to be FPGA software. It could be slower software than that. There are ways you can mitigate around that. But then you go into product.
Can you comment on what advice would you give to managers at a medical device company that want to adopt these approaches, going from a traditional approach for their product development organization?
So the little secret is it took years. The issue you have to deal with is the culture inside of the organization. We had, for us, doing the first incarnation of phase zero, we got a lot of resistance, but there was a lot of pressure from the business to get some projects done. And so I had the CEO on my side, if you will, to be able to get it done and be able to make it happen. And then we were able to demonstrate it. When we went into design control proper, we were following all the regs and everything else that we needed to do, so we weren't out of compliance and we get the product out the door. To change the process, which is going to the more V model, we had to get the head of quality supporting us completely, and that took a little bit of education. I mentioned Geetha Rao here. Geetha was a consultant for us, and there was a lot of respect because Geetha has a lot of experience with the FDA. And so it took a year to be able to, maybe a little bit more than that, to be able to put that process in place. So it doesn't happen overnight. And we were a small organization. Engineering size at that time was about 40. And so it isn't like a large company like Varian trying to do this. You have to, if you were Varian, I would try and do it in one small business unit, or if you don't have that in one project or something. And we ended up picking projects. We're doing this one, all the other ones, they have to follow their own process. And you have to prove that it works. So it's a culture change, basically.
Any other questions? So you probably have some more slides.
Not a lot more, but a couple more. One that we did at Philips, I don't know how, I guess this is really combining a lot of things. We ended up, this comes out of Lean, integrating the suppliers in what we were doing. And we ended up doing a fast, full system of taking a gamma imaging product and putting CT onto it. And what we ended up doing is bringing the suppliers in-house to make them part of the program. And sharing information, which is kind of radical in some companies, which means you're letting them see under the kimono of what you're trying to do and making sure you want to take a risk of not letting your information go out. But it was huge in terms of being able to do the development, because then it became part of the solution. And it was a very collaborative kind of situation. So you talk about collaboration, this is a way of doing collaboration with your suppliers. So this is my last slide. My perspective, I'm passionate about having an understanding of what your customer problem is. And really doing that often and iterating that as you go through the development and letting them into the development as you go forward. Stealing from IDEO, ideating, prototyping, iterating, and validating with the customer multiple times until you are close or you're at where you need to get to. Small projects. We ended up having, we wouldn't have solo projects, but we could have 2-man teams up to 6-man teams. If it's bigger than that, you need to break it down into system subcomponents, whatever it is that you're trying to do. But you want to have communication within the team. And you're building knowledge for continuous development. So this is the key part of Lean, the key part is Agile. I didn't talk about it in what we're doing here. Aaron Joseph's here, who talks about A4, how you build it into your process and putting it on, documenting as you go forward. I think that's pretty key in figuring out how to build that knowledge for ongoing improvement. And I've said this before, but I believe product development is a team sport, and it's about collaboration. It's about sharing knowledge and information. And that's it.
So if there's no questions, or no more questions, Surgeon,
Yeah, so actually, really have questions. So one thing actually that we like also to know is who's here the first time in these meetings, right? Okay, so can I just know how did you learn about this event? How did you? Okay, so yes.
I met Aaron at a bio-to-device group session. Yep, yeah.
Okay, so
Word of mouth.
Yeah. Okay, very good. Anyone else? Through Meetup? Okay, very good. Okay, so into the topic and okay. So for those of you who are coming regularly, you know that one of the things that we do is announcement, in particular job announcement. So anyone looking for a job, want to change?
Hi, Dave Snyder. I know some of you here. I'm in CISSP, background in engineering and product development, product management, but not code development. I am looking to work with device companies on cybersecurity. I have some clinical background in respiratory therapy and intensive care. And I'll be finishing up my current project in the August timeframe, so I'm starting to listen around and see who I might collaborate with.
Excellent. Anyone else?
Yeah, Jeremy Troy. I'm Jeremy Shaw. I recently resigned from a startup as VP engineering. It's a golf product, actually. And it's golf tracking, so it's a mixture of hardware and software. I'm looking to get back into the healthcare space, so I spent 10 long years in healthcare equipment, so I'm looking to get back into that space, but fairly well.
Anyone else?
Hi, I'm Alan Hackett. I've been here on and off over the last year, and met Mark Altman at another networking event. And currently a product developer. I work on new product development. I've worked at Google in the interactive retail products. I've also worked at an electric motorcycle startup last year in new product development, and also trade show exhibits. So looking for another opportunity in industrial design or mechanical design.
Excellent. Great ones. Okay. Any job announcements? Anyone hiring? Okay, then I'll go first. So I'm with Cognomotive, which is Cognomotive Oh, sorry. So Cognomotive, it's early stage startup in automotive space. This is not about autonomous vehicles, driverless cars. This is about making cars safer and more reliable using AI and hybrid AI combination of edge and cloud AI. So I have actually multiple openings for embedded engineers. So that's why I thought that those who are interested in hardware may find it interesting. Also backend engineers, data science, and data engineers. So I do have my cards, so if you are interested in, if you know someone, go talk to me. Anyone else? Okay. And by the way, I'm different watches, so.
So Larry probably has a few words about the book.
Okay.
My name's Larry. I'm the book swap monitor at the table over there in the back. And feel free to look at all the books and the CDs and take or leave. It's your choice.
Just one final point about the book swap. The point being that many of us have books on our shelves and just gather dust. So you're welcome to, you can toss the books or you can give them to Larry and then he'll bring them here and then someone else can actually read them and keep them for as long as you want and put them back in the pile. Okay, so I think that covers just about everything.
There's one more thing. We are grateful to Varian for giving us this nice space, but we also have to put it back in order. So let's try to clean up. When do we have to make it? How much time do we have for networking? Okay, so we have more time, but let's try to clean up before we leave. So.
And just remind you that we meet on the third Thursday of the month, so the next meeting is roughly 4 weeks from now. All right, thank you everyone.